Hello everyone, welcome back to my channel Ali Share Chemistry Class for All. Today I have chosen some special topics that is reactive intermediates, or which is called carbocation, carbanion, free radicals, and carbines, and plus effect, inductive effect, which are all included in basic organic chemistry. So why I have chosen this? All of you know the JAM 2003 will be coming soon, which may be in February. I think in February 12th. So only 3 weeks are remaining. So these 3 weeks I have decided to make some video which will helpful for those students who are appearing for JAM in chemistry. So let us try to stay with me. Let us try to understand what type of reactions are coming in the previous years, and regarding and considering those reactions, considering those questions, I have decided some topics, some selected questions which I will discuss today, and after that we'll make some video in regular basis. If you follow this the 3 week classes, I think it will be very helpful for you, and I request you to see the video till the end, and prepare well for the for those questions, and prepare well for your upcoming JAM examination. So best of luck for those students who are appearing. So prepare well. I'm trying, from my point of view, from I'm trying to prepare some questions for you, and with solutions. So stay with me and see the video till the end. So already written in the board, the first questions, which is related to carbocations. All of you know carbocations. Which is carbocations? Carbocations, what do you mean by carbocations? All of you know, when carbon containing a positive charge, that compound is called carbocation. All of you know that. I think fifth semester students, all of you know. If you forgot this, just read it, and remember this for your upcoming examination. So when carbon is containing a positive charge, that compounds, that cations is called carbocations. So the stability of the carbocations, when comes to in our mind, the three things we have to remember. One stability factor is Plaza effect, another is hyperconjugative effect, and last one is very important, which is resonance effect. Mainly these three factors, that is inductive effect, resonance effect, and hyperconjugative effect, will explain you which carbocation will be the more stable. So let us try to find out here the given problem. In this given problem, you see first carbocation. The first carbocation types is this carbocation types is, if you see this center, the positive charge containing this carbon. So first one is primary, but not only primary, it is a allylic or vinylic. No, this is not a allylic or vinylic, because if you see here, the double bond is present. If you give the number here, 1, 2, 3, or 1, 2, 3. So if double bond content here or here, then it will be allylic type. So this is not a allylic type also. So this is a simple primary carbocation. So the less stable carbocation among all carbocations is generally primary carbocation. So this option is cancelled. Now we move to the second options. In second option, you see the positive charge contents in this carbon. This carbon is 2 degree carbocation, 2 degree, as well as you see this position is allylic. So this is 2 degree allylic, and not only 2 degree allylic, allylic, but this is extended conjugation with another double bond here. So this total part is conjugated. So we get this carbocation is stabilized through resonance as well as Lassa effect of this group. So the stability of the carbocation is due to the extended conjugation, because it is a allylic type double bond and 2 degree also. Now move to the third one. In third one, if you see this center, here is 2 degree. Sorry, this is 3 degree carbocation as well as allylic. 3 degree as well as allylic. But if you look at closely, very closely, it is 3 degree allylic, but here some questions is written. No, this is a 2 degree allylic. This is 2 degree allylic. 2 degree allylic, but this is not extended conjugation. Just it is a simple 2 degree allylic. Here is no extended conjugation. Now move to the C. You move to the C. In C, what do you see? And move to the D. This carbon is 3 degree carbocation and as well as allylic, but there is no extended conjugations. So if you consider all the factors, the most stable carbocation will be carbocation B, because this is 2 degree as well as allylic as well as extended conjugation is present here. So the most stable carbocation will be B. I think this is clear for all of you. So the answer will be B. Now move to another problem which is also related to carbocations. This question is same. Which among the following carbocation is most stable? So number A is plus this is also 3 degree, this is also 3 degree. All examples are given here 3 degree. This is simple tertiary butyl carbocation. So if you see this problem, all carbocations are 3 degree. You see, this is also 3 degree, this is also 3 degree, this is also 3 degree, so this is also 3 degree. So how can you distinguish the carbocation? How can you predict that carbocation which is most stable? So you have to consider another factors, that is resonance factor, that is hyperconjugation factor, whatever is applicable here. Just you look at it, look at the board. If you see the first carbocation, which is 3 degree as well as benzylic, this position is called benzylic position. So this is 3 degree benzylic and 3 benzene ring is present. If anybody consider, immediately the answer will come. The first one will be the more stable, as it is benzylic as well as 3 degree. But you see here, this is 3 degree and there is 3 cyclohexyl group. There is no resonance effect that is present in benzylic carbocation, benzylic type carbocation. So here the stability factor is only the plaza effect of a cyclohexyl ring. But if you see in carbocation C, this is also 3 degree. But here the special character of this cyclopropyl group is very much important. In cyclopropyl ring, the orbitals are overlap in bent type, which is called bent orbital overlap. So this bent orbital present in cyclopropyl group will overlap with unhybridized p orbital. This is a special type of resonance which is called dancing resonance. So this dancing resonance makes this carbocation is most stable among the all carbocation events, as well as it is most stable compared to benzylic type also. And this is simple 3 degree carbocation. There are 3 methyl group present, only plaza effect. So considering all the factors, we can see that we can explain here the most stable carbocation will be carbocation C. This is due to this factor which is known as dancing resonance or bent, which is called bent orbital overlap. So it's clear. So I think this is clear also for all of you. And again, I'm going to write another problem. Same problem, but examples are different. Which carbocation is most stable? So first one, just I'm writing here. CH3, CH2 plus the CH3, CH plus OCH3, C, CH3, CH plus Cl, D, CH3, CH plus NO2. So this is very simple question. Just I am this is first class, so I am given some. I am discussing some examples, which is simple type of questions. So don't worry. If you learned it, you can explain all the types of questions. They may be difficult or nothing doesn't matter. So you see that in A, this is simple A primary carbocation, which is stabilized only plus I effect of methyl group. If you move to the carbocation B, this is also stabilized through plus I effect. But extra stability factor is the plus R effect of this OCH3 group. This lone pair is stabilized the carbocation, which is called plus R effect. So what we will get? CH3, CH double bond OCH3 plus, which is known as plus R effect of OCH3 group. Which groups are showing plus R effect? Plus R effect, the groups or the atoms which containing unshared pair of electron, that groups will show or that atoms will show plus R effect. For example, oxygen, nitrogens, halogens, sulfur. These type of atoms are will show the plus R effect. So now move to the C. Here is also present 3 lone pair. So this carbocation is also able to show the plus R effect. Here chlorine will show plus R effect. So what we will get? CH3, CH double bond, Cl plus But if you see in problem in D, here is present nitro group. If you write it properly, N double bonded O minus, here nitrogen is present plus. So here nitrogen NO2 group will show this, because of the presence this plus charge, it will show minus I effect. So when this is showing minus I effect, we know carbocation is electron deficient center. That's why this is plus. And here NO2 group also containing a plus charge. So electron deficient center, both are electron deficient center. So this carbocation will be least stable. This carbocation will be least stable because due to the minus I effect of NO2 group. Just it will be cancelled out first. This is a tricks for your for all of you. Whenever there is MCQ type of question, you just look the questions and find out which options will not be possible at all. Just cancel it out. Okay, so I have cancelled it out because this is minus I effect, NO2 group, so minus I effect, and it will destabilize the carbocation. Now we move to the remaining three. In first one, this is only a simple primary carbocation. There is no extra stability. But in B and C, there is a special character of oxygen and chlorine, which is called plus R effect. But all of you know, I think all of you know, when a group or atoms will show plus R effect, that means that atoms or groups are containing lone pair of electron. If plus R effect is present, it is obvious that the elements or group will show minus I effect, because we know oxygen is electronegative element, nitrogen is also electronegative element, halogens are also electronegative element. So when a group is showing plus R effect, that group has automatically minus I effect. So which will be the more favorable? It will depend on its atomic number or its electronic configurations or its position in periodic table. Simply its position in periodic tables. So look at this. Here is OCH3, here is Cl. Both are showing plus R effect. If you consider oxygen and chlorine, we know chlorine is more electronegative than oxygen. So chlorine has strong minus I effect compared to plus R effect. And if you see in OCH3 group, oxygen has less electron than chlorine. So oxygen has strong plus R effect compared to minus I effect. But why we say the plus R effect of oxygen is much more compared to minus effect? Because if you see the electronic configuration of oxygen and chlorine, the outermost electron in oxygen is 2s2 2p4. But if you see the chlorine atom, the outermost electron configuration is 3s2 3p5. So here is 2p, 2p, here is 3p. So you know the energy of 2p orbitals is more, energy of 2p orbitals is less compared to 3p orbital. So it is overlap, oxygen is overlap with the unhybridized p orbitals of carbon. So the matching here in this carbocation is between 2p and 2p, which is energetically more favorable. But if you see this carbocation, here is matching, here is overlap is happening between 2p and 3p. So there is an energy gap. Overlap will be better when two orbitals have comparables or same energy. Then the overlap will be the better. This is the most fundamental things of molecular orbitals. When two atomic orbitals have the same energy or comparable energy, then the overlap will be the maximum. So if you consider these two carbocation, this B and C, the plus-R effect will be maximum for OCH3 group compared to Cl. So I think this is clear for all of you. So the answer will be B. The which carbocation is most stable? The answer will be B. So I am going to erase now. Erase it now. Now move to some another type of examples, which is not a carbocations, but another types of examples, which is also included in basic organic chemistry. Let us try to explain these questions. Number 4 question is find out the most reactive nucleophiles among the following. The options are number A, water, number B, OH minus, number C, R, S minus, number D, not R, write it CH3S minus, number D, CH3O minus. So the question is comes from nucleophile. Find out the most reactive nucleophiles among the following. Reactive nucleophiles means the properties of the nucleophile. That property is called also nucleophilicity of the nucleophile. So first we have to clear what is nucleophile. Nucleophile are those compounds which have the tendency to donate electron pairs. So to be a nucleophile, it must have to contain unshared pair of electron or excess electrons. So generally we can say that all anions are acting as a nucleophile, and for those compounds, the compounds which containing unshared pair of electrons, that compounds also act as a nucleophile. So two things comes here. When a nucleophile is taken, we have to see which center is donating the electron. So just see here, in water molecules, it is a neutral molecule, but this oxygen atom contain lone pair of electron. So it will donate this electron. So this is acting as a nucleophile. And second one, OH minus. This is also a nucleophile because it contains negative charge, means extra electron is present here. This is donor center. And CH3S minus. CH3S minus. This is also donor center. So this is also acting as a nucleophile. And last one, it is CH3O minus. So all these given compounds, given anions or neutral compounds, are acting as a nucleophile. Now the questions comes, when there is a nucleophiles, the nucleophiles have also another character which is called basicity. So the terms comes, so the questions comes in your mind, which properties will be favorable for these compounds. This is nucleophile character or basic character. So the things that we have to learn. First, the nucleophilicity versus basicity. To explain this answer, nucleophilicity versus basicity. Why we call this nucleophilicity versus basicity? We know a nucleophile is those compounds or ions which have the tendency to donate electron pairs. Similarly, you see a base is a compound or a base is a compound, or specifically we say a Lewis base type compound which can donate electron pairs. So both the terms nucleophilicity and basicity are related. That is related to the donating of electrons. Nucleophile also donate electrons and base is also electron. Base is also donate electron. Now questions comes in mind when it will act as a nucleophile and when it is act as a base. Just I am trying to explain it very easily. Just listen it carefully. It is very important for all of you. So nucleosity, when nucleophiles come, nucleophiles means when it is attached with a carbon center, which is, for example, you say Rx nucleophile. We all of you know we get Rnu plus X minus. So here R is delta positive charge. Delta positive charge means it is positive charge, but this is delta. Delta means small. So this is soft center. To clear these questions, you know about the hard soft acid base principle. I'm just telling you the principle. The principle is SAP principle. Hard acid always prefer hard base and soft acid always prefer soft base. Okay, I'll discuss it later. Just for these questions, this is enough for you. Is delta plus charge. So when nucleophile comes this center, the X is leaving group is eliminated. So nucleophile attached with a delta positive charge, which is a soft center. So according to the SAP principle, which nucleophile will react faster? This nucleophile, this substrate. The nucleophile whose donor center is also soft. So the soft center is more nucleophile compared to hard center. Now the question comes in mind, which is soft center, which is base center, which is hard center. Just simply you can remember the electronegative element which are given here. If the electronegativity is high, that center will be hard, and if the electronegativity is low, that center will be soft. So now the answer is clear. You see, in all these three, water OH minus and CH3O minus, the donor center is oxygen, which is more electronegative compared to S minus. So S minus is the soft center. So according to the hard soft acid base principle, we can say that the CH3S minus will react at faster rate with electrophiles such as Rx or alkyl halide. So the answer will be CH3S minus. So again I am repeating the question. Find out the most reactive nucleophiles among the following. So the answer will be C. This is due to the less electronegativity of sulfur atom compared to oxygen. Okay. And the principle whatever we have applied here, that is hard soft acid base principle, and new things you have learned here, that is nucleophilicity versus basicity. So when the donor center is a soft, that will act as a nucleophile. When donor center is very much electronegative, that has the tendency to act as a base. Now move to the another problems. That is problem number, I think 5 or 6. I think problem number 5. Okay, no problem. Just you see what will be the problem number. Number 5. Among the following carbanion, which one is most stable? Among the carbanion, which one is most stable? So options are given here. A, CH3, CH minus, CH3, B, CH2 minus, pH, C, OCH3, CH2 minus, and D, NO2, CH2 minus. So this is very simple questions. In this class, this is the first class. So I am discussing some simple question. I have already told you. Not all questions are simple, but this is in relative to JAM, this is simple, but not too much simple also. So the question is, among the following carbanions, which one is most stable? So you learned about the carbanion first. You will learn the details in any books or any videos you can learn. So I'm telling you just simply, what is carbanion? When a carbon center is containing negative charge. In one sentence, when a carbon center is negatively charged, that is called carbanion. So negatively charged means it contains or it has more electron density. That's why it is negative. So how it is stabilized? The carbanion will be stabilized through the minus I effect or minus R effect or resonance effect. These three effects are important for the stability of carbanion. If you learn these three effects carefully, you can answer this question. Just see, the first one is a 2 degree, here is negative 2 degree carbanion, but here methyl group is so plus I effect. 2 degree carbanion, methyl group is so plus I. So plus I effect means it is destabilize the carbanion. And second one is, this is benzylic. This is special type of carbocation. This is benzylic. In benzylic carbocation, benzylic carbanion, benzylic radical, all are stabilized through resonance. We know that. So this is benzylic. So this is stabilized. So this position is called benzylic carbanion. Benzylic as well as 1 degree primary. Now move to the problem numbers. Move to the option C. In option C, this is also benzylic, but here a special character is present of OCH3 group. We have already told you OCH3 group in oxygen present lone pair, so it will show plus R effect. The plus R effect means it pushing the electron, so it will increase the electron density in CH2 minus. That means plus R effect, just like plus I effect, also destabilize the carbanion. And we move to the problem number D. Option number D. This is also benzylic type. Benzylic type. But here NO2 group is showing minus. NO2 group is showing minus R effect. All of you know this. Just I am showing here CH2 minus in double bond plus minus. So the NO2 group is showing here minus a effect. That means it will withdrawing the electron from CH2 minus. That means the negative charge density is minimum in this carbon center. We know, all of you know, the charged particle is very reactive, so that's why these particles are these compounds are called reactive intermediates. So if you consider the density of negative charge in carbon, so the density of negative charge of carbon will be less in compound D. So the stability of the carbanion among the given carbanions, the most stable carbanion will be D. This is simple. As it is first class, so I am discussing some simple problem, and after that I will do some typical problem which are little bit tough, not too much tough, just conceptual question. Just you read it carefully and you can click it. So in next class we will discuss some typical problems which may come in JAM 2023, and that is also from basic organic chemistry, that is carbocation, carbanion, acid base, plus effect, minus effect, hyperconjugative effect, etc. Whatever you have called it, this is called basic organic chemistry. So you read it carefully. All these topics you read it, just revise it. All of you know, you have to revise it. Otherwise, you can. I think in semester system, this is the problem is if a semester is over, then you forgot all of this. Just forgot all of this. So that is the problem. In our times, the system was part 1, part 2, or 1 plus 1 plus 1 plus system. So we read it carefully and we remember it for the long time. But nowadays the students are not too much I think sincere. They just mug up and then just write down in examination and get the number. But the quality of the students gradually decreases. They are focusing in the number only. They don't like to study. They don't like to learn. They don't like to listen carefully. So that is the problem. But this problem will be over if you like the subject, if you read the subject carefully from the core of your heart. So that is the basic idea to love a subject. If you love the subject, if you understand the subject, then this type of exam is very simple for all of you. Okay, so in next class we will also discuss some this type of problem which is related to basic organic chemistry. So all of you read well for upcoming jam. I will regular basis every day one or two video I will done, and you just touch with me. I will explain all the questions that may be probable or may come in the 2023 jam. So don't worry, if you learn carefully remaining 15 or 20 days, you may click the jam. This is not too much tough examinations. Just you have to remember the previous semester theory and problems. So till then, stay with me and see the video until the end, and you can send your query in by message, or you can make a comments, or you can call me directly also. You can WhatsApp me directly also. I am giving you a number today. The number is 9153581662. This is my WhatsApp number. You can send me in WhatsApp also. whatever questions have your mind, you can send me. I'll discuss in next class. Okay, if you send the questions, I'll discuss in next class. Till then, take care and read well. Okay, if you like it, then the video, you share with your friend and your colleagues. Thank you all for watching.